Hi guys, and welcome back to another video. As I've said in the past one, the parts turned up for this second SFG001. So I've got them here. I got 4 chips because I wanted to make sure I had spares in case one died. I wouldn't have to wait another 3 or 4 weeks. And also, if one of these is faulty, I have a spare. And later on, if I need a spare to repair one, I've got them. So I've got the chips. I've got my programmer out because this will also test the 7.4 series chips as well, so it'll tell me if they're faulty or not. It's about 99-98% accurate. Sometimes it says they're good and they're not. Most of the time it is. So a few tools, the meter. I'm going to have to turn on the vacuum desolderer to remove the chip. I've marked the chip as faulty, so it's black permanent marker on there. Those are the EPROMs. I'm just erasing those to make sure there is no issues with them, and I'll check them and make sure they're okay. That one I left the sticker on because it was the one that came out of this faulty one, so I can check it and see if it's any good. Those have probably got a bit longer to go. I haven't put them in the UV eraser at the moment. I'll just see how it goes with the light. I've got to dig it out and do them. What I will do is I'll plug the programmer up and I'll check these and we'll see if they're any good or not. And then I will turn this on and we'll desolder this chip and put a socket in its place. I'm ready to go now, guys. I'll switch you over to the screen so you can actually see what I am doing, and you can see me test these chips through the programmer and how it works. Bear with me for a sec as I switch this over. Okay, so here we are in the programming software, and so what I'm going to do is I'm going to go into device and logic test. So we go in and it's a 74107. Now this software doesn't like the letter descriptors in between them, so it doesn't like the LS or it doesn't like the HCT and that sort of thing. So we just got to put in the numbers, which is a 74107. So I put that one in. So I'll now get one chip and I'll pop one of these chips in, and on the programmer it shows you the image on which way it goes around, and so that's what we'll do. We'll lock it in, and then we'll come down here and we'll tell it to test. And as you can see, it's gone through and done the test, and it says everything is fine. And it does find it, as you can see down here. I told it to do an auto find, and it actually finds it as the right type of chip. So that checked that chip, and that said that that one was fine. And if we do an auto find again, there it comes up with that chip. So it just tells us that it is a 74107. So I'll put the secondary one on, and that comes up as normal. Okay, so we can do an auto find on that as well, and it finds it as the same chip. If there was an issue, it would come up down here in where this text is. The other thing with this software is it's a little bit cumbersome to get around and do things. You've got to keep reverting in backwards and forwards to typing stuff back in again. But these are cheap programmers, and as I say, in most of the stuff I've done with this, I've never had a problem with it. It does the EPROMs and the erasable ROMs. As you've seen, I've used those. I've programmed on this as well, and they work fine. I haven't tried any of the really old ones yet to see if it works, but it seems to. Test the third one, and that one comes up okay as well. And when I get a bulk load of ICs and that, second-hand ones and things like that from overseas, or in a bulk lot and someone's cleaning out and has a whole pile of ICs to get rid of and ask me if I want them and that, I use this to do the same, especially if they are ICs that are in the list. Now for this program you can go online, and it also, when you do the firmware updates for it, they do an updated list of what ICs this supports, and they are supporting it all the time. The newer version of this programmer supports more chips, but they dropped off supporting the older chips, so you get pluses and minuses with it. So all 4 of those come back as fine. What I can now do is then I'll exit back out of here and I'll swap these back over, and there you can see that those are the chips, and I've tested them all in the programmer. They're all working fine. So I'll just take this one out. They're a cheap little program. They're not expensive. So if you need something simple and easy to use, the software is still updated for it. One of these little 866s are a good little programmer, so yeah. So those are all good. So right now what I can do is I can turn this off, put it away, and then we can get around to turning the desolderer on, taking this chip out, and putting a socket in. So I'll get on and I'll switch this off and move it out of the way. You don't need to see me do that. Right, guys, and so the other thing is too is always carry a range of sockets. Now this is a drawer set I have up above me. I have drawers from 4s, 6s, 8s, 14s, 16, 18, 20s. I have a range of different ones. I also have, because I've done some odd bits and pieces with other gear in the Amigas and that sort of thing, you can get the same sort of sockets in a narrow and in a wide. So I do have some of the oddball ones as well. Like all these standards, when I buy them, I usually try to buy 50 or more at a time. And they usually come like this, stacked up, because sometimes you'll get them where the pins have been bent, and that depends on how they've been packaged. But that's what I do. I usually have a drawer and I label on it what they are, and these are 14 pin. I also have another set of the drawers with these that have the round tuned pin sockets in them. So the other ones are the round ones. I don't carry as many of those because they are quite expensive compared to these. So the round tuned ones, I try to carry at least 10 or so of each, or maybe a few more if they're a more common one. That's where I am with this sort of stuff. So I'll just put that to a side. Now what I need to do is I'll turn on the desoldering iron, and we may need a little bit of hot air to help us get this out, because it looks like it's soldered partially on the top as well. And the hot air gun, I use this to help warm the board up before I use the desoldering gun. And you'll see me do that. And what it does is it makes it easier to remove them, especially around the heavy ground planes. If you've got a lot of heavy ground planes, like this has some heavy planes in it, you'll find you can try to desolder, and you'll end up pulling tracks because you can't get enough heat into it to get it out. And this is where a hot air gun, if you haven't got one of these, you can use like a paint stripper, but turn the heat right back. These are better because you can actually control the amount of air and the amount of heat you get out of them. So they are a better option to get. You can see the type of gear I use. I did a video on tools and boards, and in that I took you through a bit of a quick run through of the stuff I do and use. So you can have a check on that. I will move this stuff a little bit, and then I will turn this on and we'll carry on. Right, as you can see there, I had a little bit of trouble with this. It's the soldering on the top, it exploded right through and over the top of the legs, and so it had been one of the pins was holding it down. So as you saw, I just used the hot air, heated it up. As I heated it up, I then pried it up on one side, and then I was going to pry up this, and I thought, no, I'll use these locking suture pliers. Now these are the ones I told you about a while ago. They are indispensable. If you can get some, try AliExpress, try Temu, places like that, and they are surgical tweezers or pliers. And what it is they have a set of locking clips down the back here that when you push them in, they're a set of teeth and they lock together, and it locks the jaws up. You can get them in different sizes. I've got these, and I've got a bigger, heavier set. I was lucky I had a friend who had a doctor that he knew really, really well. I did some work for him in PCs, and he says, "Oh, is there anything I was looking for?" And I said to him, I would really like some of those locking pliers, and he had some old sets that he didn't use, and he gave them to my mate, and then my mate gave them to me. And that's where I got them from. And they're surgical stainless steel. They're really, really good. So anyway, I won't carry on too much, but that looks pretty clean. I might just clean it up with a bit of isopropyl, and then I'll pop the socket in. Now you want to see, because the board's all good, it's not blistered or bubbled, you just got to keep an eye on your heat and use it a little bit at a time, move it around. Don't keep it in one place for too long. And as you see there, the ones I had trouble which were refilling, I heated them with the iron on it and sucked the solder out. That way the hot air kept the solder molten longer, which allowed me to get it out. And it also heated the board more, which allowed the solder inside the leg to melt better. That's not too hot now, so what I will do is later on, after we've done the socket on this, we'll put that in the tester and see if it's any good or not, okay? That was getting hot, so I'm picking it was faulty on the board, and something they've done has caused that to happen. And as you can see there was obviously a break in the insulation on this, and the heater's actually caused it to shrink. So this is the thing you got to watch with hot air. Things like that will happen. You got to be careful and watch what you're doing. I should have put some foil or Captain tape or something like that over it to keep the heat off it. But I can replace it. It's not a biggie. So what I will do is I will clean this up with a cotton bud and some isopropyl, and then I will flip it over, put this in, and we will solder this back in with the soldering iron. I'll just turn the hot air off for now. So I'll turn the soldering iron on to heat up, and then we'll get into soldering this on now. Okay. And I'm not sure you can see it, where that IC is, but there are a few heavy planes in the area of some of the pins, especially this one, this one, this one, and this one. They all tend to be in areas where there's quite a heavy plane. Now trying to get that out with just the desoldering gun, probably could do it using flux, but the problem is this flux blocks up the desoldering gun or an iron and a solder wick, but you're really going to be into the area of do you pull a pad or not. And that's what happened to this. In the earlier ones that I did, you'll actually see that this one had the pad broken, because these two should be connected together, 28 and 27. They should be connected together, and they should both have 5 bolts on them. But on this, when I was checking it, pin 28 didn't have 5 bolts, and that was half the problem we had, is that when I put a new ROM in it, which has the leg bent off the side of it on 27, it picks up the 5 volts on 28, and there was no 5 volts there. So that's why I put the wires on it and ran the 5 volt test off my bench power supply, and it had the 5 volts there, which is fine. The 5 volts was also still on here, but I didn't have the pin connected to it. It was connected to this wire, which goes down underneath here. That's the A14 line, the address line 14. That's why we pull it out and put it through there, because that line is not connected, because the original ROMs were only 16k. The one we're replacing it with is a 32, so it has the extra address line. What I did is, because we're not using it, and I have the old chip here, which still works fine, and so what I wanted to do is to make it so it was convertible to go back. So I found the instructions on how to do that, and that means that by just disconnecting this off the ROM that I put in here, putting the old one back in, you just leave that somewhere it's not going to short, and you can run the original SFG001. What I will do is I'll pour that into that, because that's my cleaning bottle where all the dirty stuff goes, not back into my good bottle. And what I'll do is give this bench a bit of a wipe, and we'll put the socket in and solder it in. so I've given that a clean and checked it over, and it all looks good. You saw me put some extra sockets on here. What this was is to build the height up so that when I turned it over, it sat flat. It's a little trick I learned a long time ago, and it also acts as a bit of a heat dissipator as well, pulling the heat through them. So that works really, really well. That's in there nice. Remember to put your notch at the right end that it shows you on the board. Don't put it the wrong way around because you'll kill the chip. So those are all done. So what I got on here, these were the ones I was telling you about on a previous video. These are IC leg straighteners. This is for bending wires or resistors, and I'll just show you. So you want a resistor at a certain width, so you put it in and just bend the legs down the side, and that gives you the exact right spacing for that setting, and it gives you a nice clean edges. And you can do different sizes all the way down to your tiny ones. Capacitors, resistors. Now these files are all on Thingiverse and a few of the other file repositories that are on the net. You can download them all. I'll put them in the descriptions down below so you can find them there as well. With the ICs, when you get a lot of these, the legs are actually splayed out quite wide. They're not actually square. So when they go in the sockets, they need to be squarer. So what you do with these, you slide it in and then just gently press the ends together, and you hear it go crunch. And that's straightened all those legs up. Really easy way to do it. You can use either side. I usually look for the flattest side and put it in. You may want to be a little bit careful. If you're printing them yourself, make sure you don't have what they call elephant's feet on the bottom. If you do, that'll cause it to have a lip on it. So do it from the other side. That's for doing the small ones. That's for doing the large ICs like the ROMs and alike. Same thing. You drop them in there, slide it down. So if they're in a little bit narrow, these are rounded, so when you push them in, they'll actually spread the legs out. You go in there, push it in, and that'll actually straighten all your pins up for you. You can do them with those. You can do them with normal ICs. There's a BDP. Same thing. It'll fit in there. Slide it down. Squeeze it shut. And that's it. And that's what they do. Couple of handy little tools. If you've got a mate who's got a 3D printer, or you got one yourself, you can print them up. There's lots and lots and lots of handy little things you can make. So those are all done. That's that chip. This is our faulty one. So what I'm going to do is I will get the programmer back down, and I will put it in and test it and see if it's faulty or not. I'm picking it as just because of the way it was heating up. So I'll do that, and then if that's the case, I will put it on the screen for you. Okay guys, so I've got it all plugged back in, locked down. So what I'll do is the same thing. I'll switch over onto the other screen, and you'll see what I see when I go and test it. Okay, so here we are. So now I will go into there to test. Now what I'll do is it's locked in here, so I'll tell it to auto find to start with, because we know in the other ones if we did an auto find, it would find them. Bang, there you go. The chip is not in the list or is not recognized. Check that the chip is put in the correct way and that the chip is in good contact. Well, it is the right way around, I can tell you that right now. So what I'll do is I will go back, and what we'll do is go into it and I'll manually put it in and tell it to test it. So it's a 74107 is what it is, and we'll tell it to test, and there we have it. So it's saying pins 2, 3, 5 and 6 have all failed. So you can look up on a schematic on what those pins are, and that will tell you. So what I'll do is I'll remove that one out, and I will put a good one in. And this is one of the good ones we've tested before, and I will now tell it to test. Bang. As you can see, this one tests fine. And this is what I was saying to you why the other one was getting hot. It had an issue. And in the good one, if we now do an auto detect, it finds it. So that's what I'm saying, that other one is faulty. Alright, just to prove a point, I will pop the good one back out again. I will pop the bad one back in, and I'll do an auto find on it. Nothing. And it says it could be faulty. We'll go back and then we'll go into here and we'll tell it to look for our faulty device again. We'll tell it it's a 74107 and we'll tell it to test, and it gives us that it's faulty. Okay, so that is telling us that that chip is definitely a dud. So now I can exit out of here and we'll go back to the main screen. Okay guys, so yep, that's the faulty one. It's got the mark on the top, that's the good one. So as I say, handy tools to have. So if you've got one and you're not too sure if it's faulty, they don't do RAM. You can get vintage IC testers as a kit and you can build them up. So you can get those and they will check RAM and all sorts of things and ROMs and everything. So a little bit better than this does. This does mainly the 7.4 and the 4.0 series CMOS TTL logic chips. It doesn't do any of your weird and wonderful processors and things like that. You need something like a vintage IC tester to test those if it supports them. This one's all done, so I will now put this away and then we'll get on, pop the chip in here, sort that wire out where it's got the break in it. We'll look at giving this a go. I'll just fire it up on 5 volts first, I think, and we'll just see if it gets hot or not. I think that's the plan. Okay, so I've cleaned it up a little bit and gotten some of the stuff out of the way. So I'll pop our chip down into here. Right way round, yes. Down in there, nice and good. And sorry guys, I've got something that's annoying my nose. 5 volts onto red and ground onto the yellow. And turn the voltage right down. And we're on nothing, so we'll slowly turn her up to 5 volts. About 5.1. Okay. So I'll leave that on for a second or two, and then what I'll do is I'll just see if it starts getting hot. Because the other one was getting hot. It was getting really hot. I mean, these shouldn't get hot at all because these are the op amps, sorry, and they need plus or minus 12 volts to run, and I'm just running 5 volts into here for the logic to see if the logic's working and getting hot. The other thing I noticed is the current draw on this has dropped right down. Before it was pulling probably about 300 milliamps with the faulty chip in it, and with the good one in it, it's down to 100 milliamps or 110 milliamps. So that to me sounds like it's actually working. Yeah. Nothing seems to feel to be getting hot, which is good. Yep, that's fine. That ROM is warm, it's not hot. They should be warm. Yeah. See, the only problem I have with this is if this chip, or this chip is faulty, it is trying to get another because they are a Yamaha chip. I think a couple I can still get. These are the music ROMs. This is a 2151. There's also a 2140 and another one. And these are very different how they work with the ROMs. The ROM I'm putting in, this, has to be altered for the address lines of where to talk to that chip. If you put the straight 05 ROM off the net on here, it's actually looking for a different ROM to talk, a different sound chip to talk to. So the ROM's got to be altered to tell it where to talk to this to start it up and where to go. It's only a couple of lines of code, but it needs to be changed. So if you got one of these and you get the ROM off the internet, stick it in and it doesn't work and it comes up illegal function call or that, you may have the wrong ROM for the audio chip on your card. Just check it. That's why I'm saying, if you need help with these ROMs and that, ask around. The other place you can do a search for it is on msx.org. The link for the file is broken, so you'll have to ask the guy that lists the ROM that did the alterations, because he still has it. That's where I got it from. Took me a few days, but I got it. If not, and you want to get a hold of me, give me a yell. I have the ROM. This seems to be fine. It's not getting hot at all. Yeah, that's doing nothing. I think this is probably going to be fine now. I think if we turn it off, we put a ROM in it, take these leads off and try it in an MSX and see if it works. I think that's my next plan. I'll switch you off here, move everything out of the way, bring the MSX up. I'll pull these wires and that off, plug it all in, we'll see how we go. Okay guys, so I checked this ROM that was soldered into the socket here, and this is actually the same style ROM as this one. So what they had was a 27C256 with the A14 line soldered to 5 volts. It wasn't going to do anything really good. That's why I'm picking that this is probably toast. I put it in the programmer. If I turn the chip ID off, I can get it to read. The only thing I'd need to do at a later date is I could dump the ROM and then do a comparison with the one I write to these to see if it's the same size file or not, or if there's a problem with it. Now you say, how do I read these and how can I program these with the pins sticking out like that out the side here? I got a socket. Now this is a 28-pin socket. This is just a pin from a DuPont, and it's the male pin. I bent it on a right angle. Now you've seen me do this when I did the Spectra Video keyboard cable. Bent it on a right angle, so therefore when I drop this chip in, it'll go in over the top, and then I just use an alligator clip to make sure these two short together. And then this pin goes down into here. That goes into the programmer and I can read it, or I can write it. But generally I'll write these before I bend the leg up, so I know I've got a good connection. But for reading them, that's fine. That works fine. So that's what I'm picking has happened, and that is probably what's caused that other chip to fail. Hopefully it hasn't damaged anything else. I can't be 100% sure with that, but hopefully it hasn't. So what I will now do is, I've got the chip in there. I'm pretty sure it's the right one for this audio chip on this card. I need to really have a look up on the documentation just to double check, but I'm pretty sure it is. I've put a bit of insulation tape over that bare piece of that wire. This is just to see if it works. So what I'll do is I'll then put the MSX up here. I'll plug this in and then see if it fires up, and if I can do the cool music on the MSX to bring this card up. If I do, then that's fixed this problem, and the chappie can have both of them back, and he'll be happy with that. Alright, so I'll get the MSX all ready and plug this card into the bottom. I'm not going to put the shields and everything back on it, just in case that hasn't fixed our problem and there's more we've got to do. As I said, most of these were fine. The Yamaha chip was a little warm, this one, but it wasn't hot. So none of these were either. But running the machine, we don't know if any of these others are going to play up without the minus and plus 12 volts on them. So I will do that. I will get the MSX out, we'll plug that board in and give it a go. Back soon. Okay guys, so here I am. I've switched it around to the front so you can't actually see me in the overlay, but I'm here. This is showing you the desktop, so I'm going to change it over to the input source for the MSX. So I'll just put it onto HDMI. If we have, I'll now just power the MSX on. There we go. And so that's powered up fine, so we'll now do a call. MUSIC, call music. Enter. And there we go. So that's come up fine. So yeah, that's working fine now. Yeah, so we've fixed it. So he must have, when he's done that, he's actually damaged that IC. So I'm really happy with that. And just to prove to you guys, here's the one that was plugged into it. originally that I had in there, the first one, the working one. So this is showing you that the faulty one is now working. Alright, so I'll exit out of here and switch you back to me. Alright, so I've now got you back. So I'll just reset everything back up and we can finish this one off. Okay guys, so there we go. So that's all fixed and done. So I will put that other one back into its case and screw it all back together. It's only 4 screws that they pop into the case. So I'll do that and then contact the owner and tell them that they're both working and that they're both set to SFG005s. He'll be happy. So I may have his other MSX to recap and have a look at for him at a later date. So sorry, I had my glasses on there. And we can do that one for him too. So we'll look at something new on the bench next. I do have some other weird and wonderful stuff people want me to do a part 2 on. So we might have a look at doing something along those lines next. And a lot of the stuff, these older machines I've got now, I've got to move them on. It's getting to a point, what am I going to do with them? Where am I going to keep them? Some of them I don't have a very big history in. And they were neat and nice to have. But they don't hold my interest. My interest is in MSX and Spectra Video. And I do like the odd weird thing. An off-spin to that is I do like the Coleco as well, which I have the Atom and I have a Coleco Vision. Now that might be the next step we go down and look at putting a TN VDP into a Coleco Vision, because I have one here. I haven't done much with it because it's PAL based. So that might be our next option. So anyway guys, thanks again for sticking with me on this one. Hope it was informative. So hopefully you've gotten something out of this video and in the way I do some of my repairs. As with everything, thanks again for tuning in. Keep safe out there. And until next time, ciao.